Here we look at the differentiation of inverse trigonometric functions. So there are three formulas that we will be visiting. So the first one, starting from the left-hand side, would be given by an example 1, and this time round I'm going to apply the inverse of sine. And when I want to obtain dy over dx, we have seen many examples when a constant is always written, and when I want to differentiate sine inverse, I simply apply the formula and we consolidate our final result and rewrite it as follows. Let's look at the second formula, and using example 2, when we want to now differentiate y, and y is given by an cosine inverse expression. So I want to obtain dy dx. The constant that we should keep is negative root 3, and applying the formula to differentiate cosine inverse, I get a negative 1 over root 1 minus x squared. And I can rewrite it this way. We see a square root in the numerator and the denominator, so we can combine them together and write it as sin. Third example is to look at how we can differentiate a tangent inverse function. And so I've given you two different variables. So this is s and t instead. So when we differentiate s with respect to t, we write it as ds over dt. And the constant negative 1.5 remains. And when I want to differentiate a tangent inverse, I apply the formula as given. And this would then be my final output.